The proton. This is fun.
Cool. Fun stuff.
Yes, I'm paying attention.
137. Can you read me the problem?
Yeah. A proton is traveling to the right at 2.0 times 10 to the 7th meters per second. It has a head-on perfectly elastic collision with the carbon atom. The mass of the carbon atom is 12 times the mass of the proton. What are the speed and direction of each after the collision?
Cool.
So I have my perfectly elastic collision equations. Velocity of final velocity of the x of 1 equals m1 minus m2 or m1 plus m2 velocity initial of the x.
And this is, okay, v1 and the x. So velocity 1 and velocity 2. Cool. Right?
Isn't your carbon atom supposed to be bigger than the proton?
Yeah. It's 12 times the mass.
What was in your picture?
Yeah, it's, yeah, you're right.
Why is there like two?
This is before and after.
Oh, sorry, never mind.
To what?
The zero.
There's two circles.
Oh.
Does that signify at rest?
Oh, 0 meters per second, yeah.
Okay.
This is that many meters per second. Sorry.
That's okay.
Okay, now that perfect. So you have your thing.
Mm-hmm.
So we'll just call this V. V times, what's the mass of the proton?
M.
M?
Oh, the masses cancel out at the end.
Yeah, plus 0 times 12m. That is equal to, it's going to be a negative, V1 times m plus V2 times 12m. So here, if you notice, your mass, you have a mass in every single one of them, right?
Wait, where did you get that?
This? This is the momentum equation. This is your mass times velocity initial. Like your momentum initial is equal to momentum final.
Why didn't we use like the energy conservation in this case?
I wonder if you could. I bet you could.
Right? That should work.
Except it's collisions, and
Okay,
it works.
all right. Better.
Yeah, it works better with momentum.
Okay.
So you have your mass times velocity. Your momentum is equal to a momentum final.
Okay.
So then from here, what do we know?
We know
Why did you
That's
put
it.
plus?
Plus,
Yeah.
right there.
Yeah.
Because you have to add the two momentums at the beginning. It's just in this case it's 0 because it's not going anywhere. Makes sense?
I thought the momentum equation was just m1 v1 equals m final.
Well, if you have two objects, then it's m1 times v1 plus m2 times v2 initial.
Those are all initials. Okay.
And that's equal to m1 final plus m2 final. m2v final. Like that. If you had three objects, then you just add in the third one on both sides. Okay.
We don't use a perfectly elastic equation.
No, we do. We did. Which one? Oh, that one? No.
You have to use this?
What else do we know? Where is it? Cool.
That's all you need to know then.
Yeah.
Crazy.
How did I solved it and I didn't need the, how did that work?
which one?
To solve for v1 and v2, because you need one more equation, but you don't use you don't need to use the, you can. I can't remember, how did I solve that one?
So I think the question is asking for the mass of. No, it's asking for the velocity.
It's asking for what are the speed and direction of each after the collision.
Oh, duh. Ah.
There we go.
Nope, I didn't have it. Is that right? No, it's not right.
There are too many unknowns.
I thought I had it.
I don't have.
Oh, the kinetic energy.
So we have to use conservation of energy.
Mm-hmm. But it's going to be 1/2 m times v1 squared is equal to 1/2 m 12m. Well, the m's cancel out.
What?
12m times v2 final squared.
But then also there would be.
Plus the potential.
No, it would be kinetic.
Well, the potential, it's on a flat plane, so there isn't any.
Oh, that's why.
There isn't any potential because it's just on a flat plane. So here you have two equations and two unknowns. That negative, it's coming out from this one. Because like if you take,
Not equal to 5.
what that is 1/2 12v2 squared minus 1/2 v1 squared equals 0. Because your v1 is going in the negative direction and your v2 is going in the positive direction. Does that make sense?
But the thing is, before collision it's V1.
Yeah.
After collision, do we know it's V1?
Something like that.
Yeah, you have two particles, 1 and 2. So
Yeah.
They stay 1. And
I mean, like, does it change or do we assume that it's same
Yeah, we assume that's
after
the same.
collision?
Yeah. Oh, no, I'm sorry. I totally forgot. Totally spaced it. What am I doing? I totally just mixed things up. I am dumb.
It's okay.
You don't do that. Don't do that. Don't do that. See, oh my gosh, I am so sorry, guys. I am so sorry.
It's okay.
For your energy equation, you need a beginning and an end.
Yeah.
Your beginning energy is that?
Yeah.
Yes. 1/2 v squared.
VI initial.
Yeah.
Initial.
And that is equal to your 1/2 v1 squared plus 1/2 v2 squared.
Mm-hmm.